Hello everyone, this is Jamie here. Welcome to another session of Expo Services. In this session, I'll be taking you through an amazing new script called DroneSiteBuilder. With one simple click, this unique script creates the match camera, fetches a 3D site with textured surface, roads, building blocks and much more. So without further ado, let's start by opening the render setup dialog and choose your rendering engine. If it's not automatically loaded already, simply choose one from the list. For the purpose of this exercise, we are going to use V-Ray. However, you can choose Corona, Arnold or any other rendering engine. Let's close the dialog. The script should now create an entire scene based on a rendering engine. Next, go to the scripting tab and choose to run script. Let's choose the DroneSiteBuilder script here and click to open it. Its settings are pretty straightforward really. This is the pipeline section here, where users set the folder to process one or multiple drone images for the same site with one click. This script works best with DNG file formats because they contain accurate camera data such as the camera lenses, the camera altitude, latitude, site information and much more. DNG files are often between 10 to 25 megabytes in size, or sometimes even bigger. This folder already contains two DNG files, which you can see here. The drone photos were taken somewhere in Florida, as you can see. As mentioned earlier, these are two DNG drone photos from the same site. You can add as many photos as desired for each site. Mind you, I wouldn't recommend having DNG drone photos from different sites. You're better off working on photos from different sites separately instead. This is the folder the script currently looking at. Because the site is in US, the terrain DEM source is USGS 3D EP. Otherwise I would have chosen the OpenTopography instead, which allows users to add the API key as seen here. It's quite easy to set up. Users need to simply click the Get Free OpenTopography API key and register for free in this website. Once you've done it, you should receive your API key code to enter immediately. This will then allow you to extract the 3D terrain data and texture from every site address in the world. For this exercise, we'll be using the USGS 3DEP terrain DEM source. Let's select the folder. This dialog is a quick pipeline summary of what the script will be doing. Click yes to continue. Click yes to accept the creation of the cameras. OK to close the dialog, and voila, it's done. With one click, the entire 3D site was created with terrain textures, camera matched, JPEG background images created and inserted in the viewport, and much more. It's worth noting that the geometry accuracy is between 1 to 6 meters. In summary, not the same level of millimeter detail you'd normally receive from specific paid 3D context model websites such as IQCities. Now that everything was created automatically with one click, the video should finish here really. However, if perchance you wanted additional areas of your current 3D site, you should simply scroll down to the fine-tuning section and click to open GeoBuild dialog. In the location section, you can type in the address and search for it. If you don't know the address by heart, simply upload the image in a Google AI and ask where this place is. You should get the correct address to type in as seen here. Copy this address from Google. In 3ds Max, paste the address. Remove any commas, hyphens and special characters for the app to quickly find the address online. Click this button to search for the typed address. As you can see here, it found it. Under Map Space section, enable the Mercator option and click to apply map space. Let's scroll further down to the OpenStreeMap section. This is the section where users add the OSM file. To create an OSM file to load here, simply click the button to open in an OpenStreet website. The correct area is automatically open because the address was previously provided and found beforehand. Simply zoom into the exact area in the map and click this tab to export. Click to manually select a different area and click to export. Click to save as and name the OSM file accordingly. Back in 3ds Max, click to load the OSM file previously saved. Before clicking to build map, let's first hide what's in the current scene. Ctrl A to select everything in the scene and choose to hide selected. Back in GeoBuild, let's click to build map and voila! Another set of 3D data was brought in. GeoBuild is also extremely useful to deploy on normal photos not taken by a drone to help the camera match and make sense of the site you're working on. Back to where things were before, let's unhide everything. 3ds Max blocked the script from automatically inserting the second background image in the second viewport simultaneously. For this reason, let's select another viewport and enable a second camera. Choose to configure viewports. In the background tab, let's enable the use files and click to load file. Choose the image 0757 here and click to apply to active view. Let's maximize the viewport and choose the wireframe override mode. Let's hide the terrain for now. Select the camera, open the modify panel, enable its target, double click on a targeted function to enable it. and select the camera target from the list. Enable the move tool and begin moving it slightly. As mentioned earlier, the OSM 3D data accuracy is between 1 to 6 meters. It's now tweaked. We can now do the same minor tweaks to the second camera. Also, when we automatically build an entire 3D scene with DNG drone data, sometimes some OSM layers, such as the building blocks and roads, might be missing. To fetch them, simply click the button to fetch Overpass OSM for current VBox. It should automatically bring in all the missing 3D data assets into the scene. This dialog lists every 3D asset brought into the scene. Click OK, and that's it really. DroneSiteBuilder requires a small studio license. If you already had one, that's great, now it's free. Having said that, within the DroneSiteBuilder dialog, users can still access other existing camera matching tools by simply clicking to Show Advanced Tools. With the current freelance individual license, you still have to Auto Detect tool. In the background mode section, you now have the new VP Overlay Plus Horizon button, the Clean Forward button, and the Hide button. Also, we now have a new feature called Crop Photo Tool. I will post a new video about it shortly. Essentially, sometimes users can't match a photo properly because it was originally cropped. This new tool allows users to extend the canvas of a new image from its horizon point set manually by the user to help match the image perfectly. So you pick the horizon by clicking on this button here. Click anywhere in the image to set the horizon line, followed by clicking to use this Y value and click to generate extended image Auto Detect VP. This concludes the video. I really hope you found it useful and I hope to see you on my next one.